with that being said, I have picked a number of questions from a certain question paper that I am not going to tell you. The reason for that, I want you guys to be able to find that particular question paper on your own, then you balance yourself. So on the screen there we have a question which reads, two charges attract each other with a force of 1.5 newtons. What will the force be if the distance between them is reduced to a quarter of its original value? Who can explain what this question is trying to tell us here? I need to hear your side, guys. What do you understand by what is being said by the question here?
Okay, can you repeat the question, sir?
You can't see it on the screen.
No, I can't. I just see physics 1, 2, 3 here. Return physics 1, 2, 3 revision session.
That's all what you see. It's physics, Prof. Gomo-san.
Oh, you can't see where I am now?
Nah.
I can see.
I can see it. See.
You can see it?
Yes.
They must fix their problem. Jesus.
I don't know your Wi-Fi, you guys. I think it's kind of weak. But anyway, I'm going to repeat the question. The question is saying two charges attract each other with a force of 1.5 newtons. What will be the force if the distance between them is reduced to a quarter of its original value? What do you get from this question before I say what I think? Huh? Mawere, please go on.
Yeah. Okay.
Mawere, your hand is up. Please go on and talk to us. Can someone say something, please?
Okay. Sorry. I was saying we have 2 points that have 2 different charges, so they attract each other with the force of 1.5 newtons. Yeah, that's
Yes.
what that's what I understand.
Okay, thank you. So yeah. Okay, so ladies and gentlemen, what is happening here now is that we have someone who is keeping on muting.
Say, we can't hear you, sir.
There's someone who is muting me from you guys. Guys, what you should know is this class is not going to benefit me. It's your class. If you keep on muting me like what you are doing, I'm going to just leave. I have a lot of things to do, like a lot. I'm not here to waste your time or what. I've got a lot of things to do. As I always do, I feel pity for you guys. But if you keep on muting me like what this other guy of you is doing there, I will just leave this class and then go with my work.
Yo, Prof, excuse, bro. First of all, I don't understand how can someone mute your own mic, like, without your device?
It's possible.
It's possible. Okay.
Yes.
I have a problem here. I can see this.
You are muted. I can't hear you.
Oh, I was saying, bro, like, I can see my slides, but they are not moving.
You are still stuck on that first slide.
Yeah.
I think funeka usimove ngokwakho vethu. Bazikhona eza arrows zikhoyo pha.
Yeah.
Okay, I'm going to try and do something. Can you see my screen?
Yes, we can see it, sir.
Okay, thank you. Still, you can see it, right?
Yes, sir. Yes.
Thank
Yes,
you.
sir, but not that page.
What are you seeing now?
We're seeing physics 1, 2, 3 revision session.
Okay, yeah, exactly. Now,
The first question.
We are seeing
The
question
questions.
one.
thank you. Those who are not seeing the question, are you seeing it now?
Yes.
Thank you. So now, so what I was saying is that this question is saying you are given two charges, né? And then we are going to say these two charges, maybe it's Q1 and Q2. And then between these two charges, there is a distance of R, né? So what they are saying is that if the setup is like that, the force between these two, it's 1.5. They want you now to recreate a situation like that. But what you are going to do, you are going to reduce the distance between those two particles. And you are going to make it 1/5 of R. So what it means is that you still have Q1 and Q2. But now the distance between them, it's R/5. So what they are asking you now is to calculate the force that you are going to get after you have reduced the distance between these two. So can you see what came on the screen now?
Yes.
Yes.
Yes,
Good.
sir.
So what is happening now is that, can you see my cursor?
Yes, we can.
Yes, sir. Yes, sir.
Okay, fine. Let me put
Yes,
a
yes.
pen like. Okay. So what is happening here? Where is it now? Let me put a highlight. Okay, what is happening here is that when the distance between the two particles, let's say you have your particle here, then you have another one somewhere here, like this. Then the distance between
Sorry,
these
sir,
two.
can you please use a brighter color?
This one you can't see.
Can't see it properly, sir.
Not really.
I think I am in trouble.
And said, and says the force correct, like it says 1.5 here, but you wrote
It's fine.
3.5.
It's fine. What is important is for me to be able to just explain to you. Yabo?
Okay, yes, yeah, I understand.
Because I wouldn't want to put the exact values there, because if I do that, you guys will not even think if the question, because this question, Dr. Fabs likes it a lot. It comes. So I wouldn't use. Okay, what kind of bright color can I use? Red. What about red?
Red or
Red,
blue, sir?
please.
Black. Hey, I'm in trouble. Red, black.
Red or
Okay,
blue, yes, yes.
okay.
That one is
This is
right.
black. This is black. How is it?
It's a
It's
good,
good, sir.
sir.
It's good, sir.
Thank you. So let's say you have particle 1 here, which we are going to say Q1. Then you have particle 2 somewhere here, which you are going to say Q2. And now they are saying the distance between these two, which is this one here, is R like this. And they are saying if you are asked to calculate the force between these two particles, remember you use, to calculate force, you use K Q1 multiplied by Q2 over R squared. Okay? So here, your R is going to be this one that we have here. That's your R. Then your Q1 is going to be this. Your Q2 is going to be this one. So now you are asked now to say, if this is a situation, the total force between these two particles is going to be 1.5. Are we together now?
Yes.
Yes, sir.
So they are saying now you have to create a situation like this again for the other part, which says what will be the force if the distance between them is reduced to a quarter. Now we are going to have same particle Q1 and same particle Q2. The only difference now is the distance between them. It's now short than what it was before. So if it's short now, they are saying it's going to be equal to R over ban. It's a quarter most over 4. Like
Over
this.
4.
So now what differs now is the distance between these two particles. So what you're going to do, you are going to solve for for F. On the first situation here, you're going to solve for F. Then on the second situation here again, you're going to solve for F. So in trying to do so, you find out that K, Q1 and Q2, they are the same. So if K, Q1 and Q2 are the same, the only difference is R. Are we together?
Yes, sir.
So if R
Yes,
now
sir.
is the only difference, if I want you to take a look at this one now, at this part here, where we are calculating F2. So when we are calculating F2, you guys, you see that we still have same K, we still have Q1, we still have Q2. The only thing that is different now from this one over here is the value of R, where we are told that it's going to be a quarter of R. So when you have a situation like this now, since we are going to square this, if you come to this part, you will see that R is squared. Then if you square 4, you get 16. So now you have a situation like this here. Are we together?
Yes.
So
Yes.
you are
Yes, sir.
told that, you were told that if you are dividing a fraction by a fraction, which is the situation what we are seeing here. We have got this, and then this is the denominator, and then we have another denominator again. So if you are dividing a fraction by a fraction, you do the invention, right? You take the denominator up. So that's why at the end of the day, you see now the 16 here. It's no longer a denominator, it's now a numerator. And then in the bracket, you have this. Can you guys see this?
Yes.
Yes, sir.
Right. What I've just
Yes, sir.
circled here, this that I've just circled here, it's exactly the same to this. Can you guys confirm that?
Yes, sir.
Yes, sir.
Yes, sir.
So what it means now is that when we reduce the distance between those two particles, the force is going to get bigger and bigger and bigger. So now, for you to be able to find F2, which is the force that you are going to get after you reduce the speed, you only need to say 16 multiplied by this number, of which this number here, this one, we were told from the question that it's equal to what? 1.5. So at the end of the day, 16 multiplied by 1.5 will give you the new force that is needed when the distance is reduced to a quarter. Did you guys get that?
Yes, sir.
Yes.
Is there anyone who is lost? Hello?
No, I think
We
not.
get you, sir. We may continue now.
Good. This question, he likes it a lot. So what usually changes are the figures. I'm sure you've seen already what in most cases it comes with 3.5. In other cases it comes with 1.5. Then this here reduced to a quarter. Sometimes you can put 50, sometimes you can put a third. But the concept is the same. Can we move to the next question?
Yes, sir.
Yes,
Let's
sir.
continue.
Okay, before we go to the
Yes.
next question, can I have someone who can just repeat what I just said?
Oh shit. Okay. Mnasa, I think you said we use this equation of the original equation, which is F1. Then we equate that F1 to that 1.5, which is given,
Yes.
right? Then our F2 will come from the new R, which is R2, which is the quarter of the old R. So
Yes.
our new R, yes, our new R will be 1/4 of the old R. Then our F2 we will have to substitute in the place of R, quarter of R to the equation. Right. Then okay. And then that quarter R will be squared. So it will be R squared over 16.
Yes.
Yes. Then when you divide the fractions, we know what to do. We multiply by the reciprocal of the denominator.
Yes.
So it will be KQ1 Q2 times 16 over R squared, which will give us that thing. Then we know KQ1 Q2 over R squared is the old force. Therefore, we'll substitute the old force in that place and multiply it by 16. Then we get our answer.
Wow, thank you so much. I wouldn't even explain it better than what you did. Thanks so much. I really appreciate it.
Okay.
So you guys, you got it right? I think it's clear.
Yes, sir. It's clear,
Yes,
sir.
Thanks
It's
so
sir.
much.
clear.
Yes, sir.
Let's go to the next question. Right. The next question here, it comes. It's saying a sphere has a charge of, can you guys see the question?
Yes, sir.
Yes,
Yes,
sir.
sir.
We can.
A sphere has a charge
Yes.
of plus 8 microcoulombs. What is the net charge after 6 times 10 to the power 13 electrons have been placed on it? So in a situation like this, you are told that you have got this particular charge, and then you are going to add this number of electrons. So, okay, you have got this charge here, this one. And then to that same charge, you are going to add this to it. So at the end of the day, they are saying, what is the net charge after this number of electrons have been placed on it? I want someone who can give us the relationship between a charge and the number of electrons. What is the relationship between those two? Huh? Colleagues?
Prof. Sorry,
What is
sir.
the
I
relationship
think so
between
it's Q equals
a
to
charge?
NE.
Good.
I think it's
Thank
Q
you.
equals to NE.
Thank you so much. So a charge, colleagues, which is Q, a charge is represented by Q. Then N means the number of electrons. Okay? So if you are asked now to give a relationship between a charge and number of electrons, you get it by just saying Q is equal to NE. So in this case, they are telling you that a sphere has a charge of that. So what it means is that you have got a Q, which is equal to that. Now, you have a Q, which is equal to this. And now they are saying, what is the net charge after this number of electrons? So here you are given N, which is going to be equal to this number over there. That's your N. And they're saying, what is the net charge? So the net charge, the Q that you are going to get at the end of the day is going to be equal to what? That's what this question is saying. Can you guys try to assist me in solving this one? What do you think we need to do?
6.0.
6.0 times 10 to the power 13. What are you guys getting? Nothing. Okay, guys, what is happening here is that initially you have your Q as that. And then when they say what is the net charge, you also need to get the value of Q after you have added these electrons. When you guys are quiet, I sometimes I get lost to think whether you are getting me or you are still there or you are no longer there. That's the reason why I always fail to continue.
I mean, I'm still lost, but I'm following.
I'm
You still lost?
as well.
Okay, fine. Let me try to remove these. Okay, let me start by asking what I've asked you before. What is the relationship between a charge and an electron? Sorry, and the number of electrons. Okay, so someone answered and say Q, which is a charge of a particle, is given by Ne, which is number of electrons. Nah? So here they are saying you have got a sphere that has got a charge, that 8 there that you are seeing. And then they go on and say, what is the net charge? Net charge, what they mean is that from what you have now, assuming that you are either going to add or subtract, at the end of the day, what is it that you are going to have? So in other words, in this given situation, we have 8. It's either we are going to add or subtract after we have calculated to see how many charges are we going to get when these electrons are added. Is it making sense?
Oh, okay, I understand now.
You already have 8
I understand.
and you are going to add electrons. After you add those electrons, in terms of charges now, what are we going to have? So in other words, you're going to convert these electrons into charges, then you add them to this. Is it making sense?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Sure. So let's convert those electrons now into charges. So it's either you can just make that smaller e subject of the formula, then you see how to convert electrons into charges. I think physics is one of the subjects that is very difficult to teach online.
Sir, please repeat what you said. You said we should convert the charge. We should
We
convert
have
the
to
electron.
convert these electrons into charges. Once we get the number of charges from these electrons, we are going to add that number to the charge that we already have. So this question, you can solve it in 2 ways. It's very easy. It's either you convert this 8 value into electrons, then you add the 2 in the form of electrons. After that, then you convert all of them into charges again. Or you can just come to these, you convert them into charges, then whatever that you are going to get, you add it to this. So the question is saying, what is the net charge after you add these electrons to this? So let's convert this into a charge. What are we going to do? Guys, you know that Q is equal to NE, isn't it?
Sorry, sir.
Yes, we're going
Sorry,
to
sir.
Yes, go on.
I think, sir, you will multiply 6,0 times 10 to the power 13 with 1,6 times 10 to the power negative 19.
Good.
And
Why are we multiplying by 1.6 times 10 to the power negative 19?
we want to get a charge, sir.
Good. So 1.6 times 10 to the power negative 19, that's the value of E. We are saying on the formula Q is equal to NE. Here you are given N. E is always given in your start guide as 1.6 times 10 to the power negative 19. So now when you multiply this value by E, you are going to get a charge. The charge now that you are going to get, then you add it to this one that is already given. Then you get your final answer. Thank you very much, the previous speaker. Did you guys get it?
yes. Sorry, sir. I just have a quick question. Will the charge be negative or positive?
But here they are saying electrons. They might be negative.
It will be negative. So we have to multiply by negative 1.6 times 10 to the power minus 19.
Yes, but are you getting the sense already? Because here they are saying, what is the net charge after these electrons, which means they are negative. And then you are going to multiply them by E, which is also negative.
Oh, okay.
So they will cancel each
Okay,
other.
so-
At the end of the day, they will become positive.
Okay.
Did we all get it?
Yes, sir.
Are you guys serious?
Yes, sir.
So this is
Yes.
what is, this is a situation here. Okay, let's take a look. This is a different question, you all. Okay, it's not this one. I just use the question for the sake of making what?
Making sure we
So here we
understand.
have, good, because if I give you exactly what it is, you guys can just take it in, and I'm just trying to avoid that. So here, the idea is that you are going to add, sorry, you are going to convert this number here into Q. So these are electrons, these ones, they are electrons that you are given here. So in trying to do so, that's why you see here it's written Q2. Q2 simply means the value of the charge that you are going to get after you have converted electrons into a charge. So the electrons here, they are these ones, multiplied by, since we are taking our formula which says Q is equal to N E. So the N now is this, then the E is that. Okay?
Okay, so I'm now confused about the part where you said the electrons will be negative and the charge will be negative too. Then it will cancel to positive. But here the electrons are positive and the charge of electrons is negative.
I think when this one was being prepared, the person who prepared this didn't have in mind that electrons means negative, protons means positive. So I think for the sake of this module, let's avoid putting a negative here. Are you guys getting me?
Yes.
Yes. So even when they say electrons, just take the number as it is, which means you write it without a negative. But in place of electrons now, here on the formula Ne, in place of E, you see that negative now, it's appearing. So you can take this one as it is, then for electrons, you take it as negative. Then when you multiply the two, you are going to find what? The value of Q2. So now the net charge will be the old charge that we had plus what we are going to get after we convert these electrons into a charge. That's why you see then that the writer here comes and say, therefore the net charge is equal to Q1 plus Q2. So when you add the two, what you are going to get is what the question is asking you to calculate. Are you guys getting me?
Yes, sir.
Thank you. Everyone, are we on the same page?
Yes, sir. Yes, sir.
Yeah.
Thank you.
Can you please repeat, sir?
Okay, I'm going to repeat. Let me remove all this mess that I just. Okay, so here the question gave you a charge of this value, and then they go on and say, what is the net charge after these electrons have been added to this? So in short, what is going to happen is that we are going to add these electrons to this charge here. This is what we are going to do. So for us now to be able to do that, remember this is a charge and these are electrons. So to speak in general terms, these are goats and these are cows. But they want you to take these cows and put them into goats. So you can't do that without converting one of these. So what we are going to do, Tina, we are going to convert the cows, ne? And make them goats first. Then we'll put them into the goats. So to convert these now, there is a formula which says Q is equal to N E, where N is the number of electrons and E represents electrons. So what you need to do here now is to convert this number of electrons that you are given here into Q. So to do that, you just have to take this number, you put it in place of N, then in place of E. E is always given in your start guide, and the value of E, it's 1.6 times 10 to the power negative 19. If you go to your start guide, you go there and you find the value of E. So if you multiply N and E, you are going to find Q. The Q that you are going to find represents the charge that you can get when you add these electrons. So this is going to be your new Q. Now you are safe to say this new Q and put it to the old Q. And then whatever that you are going to get after taking the new and the old is going to be your net charge. Did I make myself clear?
Yes, sir.
Thank you. Those who didn't understand it first time, did you get me now?
Yes, sir.
Doc.
Yes.
Thank you. Let's move on. We are moving on now. Right. We have another question here. Hey, this one is going to give me a headache. It's so big. Do we have Manchester United supporters here?
Yes, big time. He's caught.
Yes, yes,
Why
Yes.
do you ask? Why
Yes,
ask?
yes.
Are you Man
Yes,
City?
yes, yes. We are winning.
I can't be Man City, can go. Okay, it's fine. I wanted to hear if there are Manchester United supporters here. Fine. I will say why did I ask when we are done with the class. Okay, the question reads, two identical small insulating balls are suspended by. Okay, this one I think I will need to explain with this one here so that it becomes very clear. Two identical small insulating balls are suspended by separate 0.2 meter thread that are attached to a common point. Okay, on the ceiling. Each ball has a mass of that. Initially, the balls are uncharged and hang straight down. So what the question is saying is that at first, so ladies and gentlemen, this is the ceiling. Okay, let me take a pen that is a bit smaller. Now I can't even see my pen. Can you guys see that? Or we agreed on black?
Yes, it's yellow.
Okay, let me try to use black as you guys advised me. Can you see this now?
Yes, we.
Yes,
Yes, sir. Yes,
So
sir.
what the question is saying is that initially, the balls are uncharged and hang straight down. So you have two threads of the same height. I'm gonna try to make them two. Oops. Hey. Right? It's difficult in Zimaland. Okay, right. So you have got two balls, and then each ball has a mass of, this is the mass of each ball here. And then the thread, this thing that is hanging from top to bottom is said to be, is said to be 0.25 meters here. So the length of the thread from this point up to this point is 0.2 meters. So you are told that initially these two things, they are uncharged. When they are uncharged, it means they can come into contact. There is nothing happening between them. So they are then given the identical positive charges, and as a result, they will spread apart with an angle of 36 between the threads. So what is happening is that at first, these two threads, they are uncharged. So the moment we, sorry, hey man, this thing, now I'm going to remove everything. Okay, so they are hanging down. I send Zima too. Whatever. They are hanging down here in a straight line at first when they are uncharged. Ne? Remember, just take these as two things. Ne? So when we charge them now, we are going to give them a positive charge, all of them. So when we do that, remember, like charges repel and like charges attract. These ones, they are like, so they are going to repel each other. So what is going to happen is that, what is it that is going to happen? If they repel, the other ball will go this direction. Then the other one will go this direction. Okay? But what is equal about these things is the distance of the thread. This one is the size of the thread. That's what is equal, as well as the angle that they are going to make with respect to the point of origin here. So if that happens now, the other ball will come and stop here. The other one will come and stop there. So I'm going to remove these, then explain using what is on the diagram. So if that happens, you have your ball here, you have another one here, and we are told the size of the thread here and here, like this. And then the question says, draw a neat diagram showing all the forces acting on each ball. So if we are to start with, let's say this side of the diagram, this one here. Now, if we come somewhere here at the ball, then we look for all the forces that are acting on this ball. Remember, the ball is being hanged by a thread. When you are hanging something by a thread, it means there is a force of gravity acting against that particular ball. That's why you see here, there is this force that is going down. And that's the force, the weight due to gravity, mg. Okay? But since this ball is being repelled by this other ball on the right side, so the force caused by this ball on this one is the one that you are going to see going to this side. Are we together now?
Yes, sir.
Good. So the force that is going to the left is the force due to the repulsion caused by the other ball on the other ball. Then, since this thing is being hanged to the ceiling by a string, we expect to have the forces acting both in x-axis and y-axis with respect to the tension force applied by the object onto the string. So if we come to, let's say, let's take a look at this line, this one here, this one, and we know that the angle at first here, somewhere here, is 18. This one. Are we together? I want you to take a look at this triangle that I'm making here. So here you are told that this is your T, this one. Your T is somewhere here. Right. And you have got an angle of 18 somewhere here. So you want to know this side here, this side with respect to T and the angle. You also want to know this side with respect to T and the angle. So this side, this one here, with respect to T and an angle, since it's the side that is adjacent to the angle, it's going to be T cos theta. Why? Because it's adjacent to the angle. This side, it's going to be T cos theta. Then this side here, since it's opposite the angle, it's going to be T sine theta. So at the end of the day, since this line here, this one, is the same or is parallel to this one, that's why you see this one being called T cos theta. It's simply this line that is equal to this. So you can choose to write T cos theta here, or you can write on this side. Why? Because these two lines, they are the same. Then this one, since it's opposite, that's why you see this force down here. Did you guys get me?
Yes, sir.
Everyone, can you confirm?
Yes, sir.
Yes,
Because this
sir.
question
Yes.
is one of the questions that he likes a lot. So that's what is happening on this side. Now let's try to go to the other side. It's still the same thing again. Now we are going to look at this side. Okay, let me put this line. So we are going to take a look at this side now. This one. Right, on this side, first thing first, since this thing is being hanged from the ceiling, so we expect to have weight due to gravity going down. That's why you see mg at the bottom there. Then, since this ball is being repelled by this one here, remember all of them, they are positive. So this one, when it applies force to this one, it's going to repel it to the opposite side, this side, like this. Then, when we are taking a look again on the triangle, which is this one, this then goes down here, then it goes like this. You know that we have an angle here of 18 degrees. So if we want to express, remember this one is the tension, this one, that's your T. So if we want to express this side and this side with respect to the angle and tension, since this side here, this one, since this one is opposite the angle, it's going to be T sine 18. And since this one is adjacent to the angle, it's going to be T cos 18. Remember, this one and this one, they are parallel, so they are the same. So you can choose to write your T cos theta this side or this side. Is it clear?
Yes, sir.
Yes, sir.
Everyone,
Yes.
is it clear?
Please
Yes.
repeat.
Should I repeat? Okay, fine. Okay, so as I was saying, first thing first, since this ball is being hanged from a ceiling by a string, this is a string, so you expect it to have weight due to gravity. That's why you see mg here. It's the weight of the ball due to gravity. But the same ball, this one here, is being repelled by this other ball. Remember, they all have positive charges. So this one is going to repel this. So when this one is being repelled, it is forced to go to the other direction, which is this side. That's why you now see F1. F1 simply means the force applied on this ball by the other ball. So you see this one going this side. Then, since this ball is being hanged from the ceiling, you expect the tensional force to have an effect. But the tensional force is being applied at a certain angle. Therefore, you should have a horizontal and a vertical component of the force. So to try and find those horizontal and vertical component of the force, you have to complete this triangle here. This one. This triangle over there. So when you complete this triangle, you will find then that you have got an angle here, which is 18. And this angle, with respect to this side, it's opposite. And with respect to this side, it's adjacent. So the side that is adjacent to the angle, we call it cos. Therefore, you expect this side here, this one, to be T cos 18. Then you expect this one, which is opposite, to be T sine 18. But since this side is parallel to this side, you can choose to write your T cos 18 this side. It's the same. You can either write it here or you can write it on this line. It's the same. These two lines, they are parallel. So you can write wherever you want. So at the end of the day, the forces that are acting on those two balls are the force of repulsion. So you have this, you've got the weight here, you've got the vertical component, you've got the horizontal component. So these are the forces that are acting on this ball on the left hand side. Then if we go to the right hand side, you've got the vertical component, you've got the horizontal component, you've got the force of repulsion, you've got the weight due to gravity. So at the end of the day, these are the forces that are acting on the ball. Are we clear now?
Yes, sir.
Good. So if sometimes the question will go on and ask you to calculate the force that is acting on each ball. So ladies and gentlemen, when you are calculating the force that is acting on each ball, you use one side. You choose the side that you want to use. If you want to use the right hand side, you just use these things that are on your right only. If you want to use the left, you use these things that are on your left side only. Don't equate them, because if you equate them, they are equal to each other, you will get a 0. Are we clear?
Yes, sir.
Yes, sir.
Good. So if a question asks you to find now the force acting on each ball, you will use the forces on one side only. So what do? You come to, let's say you choose to use the right hand side only. So what you will do is that you will find the summation of forces in X. Then you also find the summation of forces in Y. So when you are looking for summation of forces in X, you have this and that. When you are looking for summation of forces in Y, you have this and that. So when you deal with these two now, when you find the magnitude of these two, using what we did in first semester to say, when you want the magnitude, summation of all the forces is given by the square root of summation of forces in X squared plus summation of forces in Y squared. Then you can be able now to find the force. Okay, let's not talk about it, but I just gave you a clue, because sometimes he can give you a question like this and then end there, but sometimes you will go on and ask you to find now the force that is acting on the ball. I think now we have a clue. Is that fine?
So can you please repeat the part where you spoke of calculating a force of the ball, force acting on the ball?
I said when you're asked to do that, you choose one side that you want to use. You can either choose this side only, or you can either choose this side only. And then when you do that, let's say we choose the right side, you have to find the summation of all forces in x-axis. So when you are looking for the summation of forces in x-axis, it's this one minus this. Ne? That will give you your summation of forces in x. Then when you are looking for summation of forces in y, it's this minus this. That will give you summation of forces in y. Now, when you want to calculate the magnitude of the force, which is the big F, so your F now is going to be equal to the square root of summation of forces in x squared plus summation of forces in y squared. Then that will give you the force acting on the ball. Am I clear?
Yes,
Yes,
sir.
you are.
Yes, sir.
Okay, thank you. So can we go to the next question?
Sorry, sir.
Uh-huh.
I have a question on the first one in the right hand side.
Uh-huh.
On this formula, say why do we only have F which is equal to KQ squared over R squared?
Oh, the reason for that is okay, go on.
Can't we use the formula for finding the force that we talked about, like in the previous question?
Yeah, it is exactly this one, but the balls are identical. So Q1 and Q2, they are the same. So you can just write them as Q squared, or you can put Q1 or Q2. It's up to you.
Okay, thank you.
You got what I'm trying to say, right?
Yes.
Good. Anyone with a question again? No one.
No one, sir.
Okay, I'm going to ask Mina, why were we using 18 here when we were resolving? Here we're using 18 degrees, 18. Why were we using 18? Where did 18 come from? Because on the question there is no 18.
Because the perpendicular line which bisects, the perpendicular line which is perpendicular to the distance between the balls bisects that angle. At 36.
Thank you. Thank you so much. Yeah, you guys, you are following, I can see. And thank you for that. So now let's go to the next question. Right. The question says, two particles with identical positive charges and a separation of that. So this is the distance
Sorry,
between
sir,
them.
I can't.
You can't see the question.
I can't. Sir.
Others, can you see it?
Is it another question?
Yes.
Yes, we can see it.
No,
Now.
sir, we
I
can't.
still see the previous one.
Can you see it now?
Yes, we can
No,
see it.
Okay. Does anyone know Little Nas? Huh?
Yes, I know him.
Come again, sir.
Okay, it's fine. Let's go on. So I was saying, the question says, two particles with identical positive charges and a separation of that are released from rest. So when you are doing questions like these, guys, you should be having something in your mind. You have got two particles which had a separation of that. So you've got this particle here, you have another somewhere here. And then the distance between them is what they call the separation. This one here, that's R. Ne? R, this one. So they are saying, and they are released from rest, which means they were resting. Okay? So whenever they will ask for velocity or what, you know that initial velocity, which is V naught or U, is 0. Immediately after the release, particle 1, this one, assumed A1, acceleration 1. So particle 1 had A1. and particle 2 had A2. And you are given the magnitude of A1, which is this one, 4.6 times 10 to the power 3 meters per second squared. While particle 2 has an acceleration 2, and you are given also the magnitude of acceleration 2, which is this one. And then they go on and say particle 1 has a mass of that. So you are given mass of particle 1, which is m. Ne? Then they go on and say find the charge on each particle and then the mass of particle 2. So they want you to find the charge on each particle. And what you should know is that these particles, they are identical. So whatever the value that you are going to get for Q1 is equal to Q2. So here now what they're saying is that find the charge. So for you to be able to find the charge, you need to find the force, isn't it? And till now we know that F is equal to K Q1 multiplied by Q2 all over R squared, like this. So this is the formula that can make you get what? Q. But here the information that we have is telling us otherwise. So this information is telling us that you have got acceleration and mass. And this, if you go back to what we did, you can find out that there is a Newton's law which talks about finding a force when you've got mass and acceleration. Which law is that?
Second Newton's law of motion.
Good. Second Newton's law says F is equal to ma. So in this case, in as much as we know that we calculate F using this formula, there is also another way of calculating F. So you can equate this thing to ma. Are we together?
Yes, sir.
Hello?
Yes, sir.
You guys, can you talk, man?
Yes, I will hear you.
One person is hearing me, then the other one is not. Guys, can we talk so that we can move forward?
Yeah, let's move.
We are hearing you, sir.
I need 10 people
Yes, we
to
can
confirm.
hear you. Can hear you,
We
sir.
can hear you. Yes.
Other voices are repeating here.
Yes, sir.
Okay, fine. So what I was saying is that in as much as we can use K, Q1, Q2 over R squared to calculate F, there is also another way where we can use MA to calculate F. So in this regard now, you are given M here for particle 1, and you are given A for particle 1. So you can substitute the value of M for particle 1 by this value here. Then the value of A for particle 1, whatever, by this value here. So if you multiply these two, you are going to get F, right? So after you get F, since you know that Q1 and Q2 are identical, as the question said, you are going to just make these two into Q squared. So you write these as Q squared so that you won't confuse yourself. So you know the value of K, you know the value of R, it's given. So you will be able to make Q squared subject of the formula. After making Q squared subject of the formula, then you can be able to find the value of the charge. Are we together?
Yes, sir.
Is it clear?
Yes, sir.
Yes, sir.
Thank you. So let me see if I have. Okay, yeah, this is what I was saying. So this is your particle number 1. So you find your F being equal to M1A1. Then you find this one being equal to M2A2. And you are given your R. And this is your formula to calculate F. So you simply have to put Q1 and Q2 as Q squared because they are identical. When you do that, so you can be able to use F for particle 1 to find the what is it? The Q. Why? Because that's where you are given M and A. So when you do that, you have to make Q squared subject of the formula. Here. So when you make Q squared subject of the formula here, then if you do all your math, this is what you are going to get. Is it clear, guys?
Yes, sir.
Yes,
Good.
sir.
So
Yes,
once
sir.
you solve for Q,
Yes.
you can now be able to find M2. Why? Because you now have the value of Q. So you can just come here for 2. M2 is going to be equal to M1 multiplied by A over A2. The reason, okay, I want to show you something here on this slide. The reason why we are saying M1A1 is equal to M2A2. In other words, we are saying F of particle 1 is equal to F of particle 2. The reason why we are doing that is because these two things, they are going to repel each other. From the same distance, they're going to repel each other. So when they repel each other, this one is going to move to the left and this one is going to move to the right. The force of moving to the left is equal to the force of moving to the right. That's why you can see them being equated together here. So from this now, you can be able to make M2 subject of the formula so that you can be able to find the value of M2. Is it clear?
Yes, sir.
Good. Let's
Yes,
go to the next
sir.
question if there's no one with a question. There you have it. A charge of Q1 is fixed at the origin of the coordinates. Okay, so you have a coordinate here. You have something like this. This is your coordinate. So they're saying Q1 is fixed at the origin of the coordinates. So you have your Q1 here at the origin. That's where your Q1 is. A second charge, which is Q, is at X is equal to 3. So we are going to assume that this is X is equal to 3. That's where you have your Q here, like this. So they told you that it's X is equal to 3, which means here it's 3 meters. The radius is 3. Yeah? Then, since they said it's at X is equal to 3 and Y is equal to 0, it's this point here. Then they went on and said a third charge of Q3 is at X is equal to 6 and Y is equal to 0. So we are going to assume that that point is here, somewhere here. So that's where you have your Q3. That's your Q3 there. Then the question goes on and say, what is the magnitude of Q if the resultant field at X is equal to 9? So you are told that the resultant is at X is equal to 9 meters. So X is equal to 9. Let's assume that it's somewhere here. That's where you are going to have your resultant. Since they are saying resulting field, it means it's the electric field. Ne? Electric field. So they are saying the resultant is here and it's directed to the right. So you have E at this point. And your E, it's going to the right. It's going this direction, like this. Your E is going to the right, like that. So ladies and gentlemen, if we look at Q1, let's start by looking at Q1. Q1, with respect to this point, what you are just going to do, you are going to look for the effect of all these charges, Q1, Q2, and Q3, with respect to this point. And remember, it's directed to the right. When they say it's directed to the right, there is a meaning for that. So let's start by looking at Q1. Q1, it's this particle here. And from the question, it's positive. So if it's positive, its effect to this thing, okay, I'm going to put E here just to make explanation easier. Q1's effect to E is that since Q1 is positive and we are talking of an electric charge, it means Q1 is going to have an effect somewhere here. Then this one again, what is it? Q, it's also going to have an effect in the same direction again. Then we have what? Q3 in the same direction again. But what is going to differ now? Okay. What is going to differ now is the distance between the two. For instance, the distance between Q1 and E, it's what? Huh?
9 meters.
Hello?
It's not. So
Good, it's 9. So here you have 9. The distance now between Q2 and E, it's going to be 6. Then the distance between Q3 and E, it's going to be 3. Are you guys seeing this?
Yes, sir.
Good. So when
Yes,
you
sir.
are done with this now, you can then calculate your electric field. Electric field, it's given by E is equal to K Q over R squared. So what matters for this question, ladies and gentlemen, it's this part. If you don't get it right, you will lose the marks. So where in place of Q, you put Q1 when you are calculating E1. So here you are going to calculate E1. So the resultant, since the question is saying what is the magnitude, the resultant here is going to be equal to E1. So you have E1. Then you have E2. Then you have E3. So if you add E1 plus E2 plus E3, they are going to give you the magnitude. Okay? They're going to give you the magnitude. So let me bring down what this person has done. So you can see here you have got particle 1, you've got particle 2, and then you've got particle 3. And then this is where everything is going to happen at this point here. And we are told that our electrical field is acting to the right. That's why you see E, it's going this side. Okay? So you will need to find E total. E total is found by calculating E1 plus E2 plus E3. Where, sorry. So when you do that, remember you are told that, where is that part? You are told what is the magnitude of Q if the resultant field, what is 30 newtons per coulomb. So what it means is that when you find your E1, your E2, and your E3, when you add these, remember they are going to give you what? The resultant, which is going to the right. So they are going to be equal to E total, which is ET, which is equal to 30 newtons per coulomb. So your ET is equal to 30 newtons per coulomb. And the reason why they told you that it's going to the right, it means this value of 30 newtons per coulomb is going to be positive, ladies and gentlemen. Next time they will come and tell you that it's directed to the left. That means your value will be negative. Did you guys get me?
Yes, sir.
Good.
Yes, sir.
So what you're
Yes,
going to do, you're just going to calculate E1, E2, and E3. Then you equate it to the ET, which is 30 newtons per coulomb. So in doing so, you will find then that there is going to be an unknown, and that unknown is going to be, it's going to be Q. And then you make Q subject of the formula, then you'll be done with the question. So this is, you see, here Q is the only unknown that you have here. Here. Then you make Q subject of the formula. At the end of the day, when you punch, then you have your answer. Are we clear?
Sorry, sir. Sorry,
Uh-huh.
sir. I have a question. How is
Yeah,
it
please
clear
go on.
that? Okay, how is it clear that the electric field acting on Q is directed to the right and
I
not
can't
to the
hear you.
left? I'm saying, how is it clear that an electric field acting on Q is directed to the right and not to the left?
Okay, I'm going to try and address that. Let's get back to the question. The question says a charge of Q1 is that, then a second charge Q is at that, and the third charge is that. Then they said, what is the magnitude of Q if the resultant field at what is directed to the right? So basically what happens to the issue of electric field, this you should know if you didn't know, there should be a point which has got charges, and that point, its job is to attract everything from wherever it is. When we are talking of electric field, there should be one point that is attracting everything. So the moment you go and put a point, let's say here, né? So what it means is that all these things, they are going to be attracted to that point. I'm not sure if I've answered you.
Okay, so does it mean that point has a charge, a negative
It
charge?
has a charge, and a point is usually positively charged. When we are speaking of electric field, a point that you create, it's always positive.
Okay, okay. So
what it's going to do,
okay.
it's going to have an effect on all these things, all of them. You can go on and ask.
Okay, but how about these three charges? Aren't they positive also?
They are. Did you see when before I brought this, I gave you guys something like this. I gave you a point here. Then I said Q1 is going to act this side, Q2 again, this side, then Q3, this side. Did you see something like this when I gave you, before I brought this?
Yes, I did.
What I was telling you is that, you see this point, it's going to force this point here to have something like this.
Oh my God.
This one, likewise. Then this one, likewise. That's why you see all my arrows, they are on the right side of the point. Did you see that?
Yes, sir.
Did I answer you?
Yes. Yes,
Okay,
I
thank you.
think I understand.
Thank you. Anyone with a question again? Is it clear?
Yes, sir. Yes, sir. It is clear.
Sure. Let's finish. I think
Yes,
we are
it's
almost done.
clear.
I think just one question left. Just one question left, I think. There it is. The velocity of a particle m, sort of a particle which has got this mass. The mass of the particle is that, and the charge of the particle is that. At t is equal to 0, so you are given that its velocity at t is equal to 0 is this. So in other words, the initial velocity is 20 and is in the positive x direction. So if the particle moves in a uniform electric field, it's important that you note this. In the positive x direction again, what is the particle speed at t is equal to 5? So you can collect data here, given that t is equal to 0, then u is 20 meters per second. Then E, the electrical field, E, is equal to 20, which is also equal to, I'm sure you guys know this now. E is equal to what? In terms of F. Hmm? Hmm?
I think
Ladies
it's
and
F over
gentlemen,
Q. I think it's F over Q.
F over Q, right? You are right. So E is equal to F over Q. Is there anyone who doesn't understand why E is equal to F over Q?
Yes, I don't understand.
Okay. If you go to the, okay, but you know what is the formula to calculate E? Do you know that? Huh? Hello? Do you know the formula for calculating E? The normal formula, not this one of F over Q. Then how can I assist you when you are disappearing? So I'm going to assume that you know. Do I still have people here?
Sorry, sir. I'm having trouble with my mouse, sir.
Oh, okay. But I was asking, do you know the formula to calculate E, which is not this one of F over Q?
Yes, sir.
E is equal to KQ over R squared. You know that, right?
Yes, sir.
Good. So I want you to just take a look at this, which is equal to, since I'm calculating E most, F, what is F? F is equal to K Q 1 over Q 2, like this, divided by R squared, like this. That's F, né? But the formula is saying F over Q. So I'm going to say divided by here. Then I will put Q, like this. Are you seeing anything? Are you seeing anything?
Yes, sir. I can see.
Good. So this formula works
Yes, sir.
when
Yes,
the
sir.
when the particles are identical. So when the particles are identical, you assume you have these ones as q squared because they are the same. They are all going to be the same. So if they are going to be the same, you've got a denominator that has got q here, and you've got a numerator that have got two q's. What do you think is going to happen to one of the q's?
It's going to cancel.
Cancel each other out.
They are going to cancel each other out. So when they cancel each other out, you are going to have this one disappearing, maybe with this one disappearing. And what you are going to be left with is going to be kq over r squared, which is exactly the formula for E. That's why E is always said to be equal to F over Q. Did you get me?
Yes, sir.
Thank you.
Yes, sir.
So now I'm going to try and explain what I wanted to explain. So what I was saying is that E is equal to F over Q. And here we are given that it's equal to 20, like this. So the question is saying, what is the particle speed at t is equal to 5? We need the final velocity. We are given the initial. We are given the mass. So when you know the mass, and then you know the charge and the time, there is something that you can get, and that is acceleration. Since we are talking about force, remember, there is obviously a way where we can get acceleration, because we know, Tina, that F is equal to ma. F is equal to ma. So from the electric field, which is 20 that we are given, you can use this to get back to force. Then when you get the force now, you can use the force that we have gotten to say F is equal to ma. And that's the reason why you are given m here, so that you can calculate A. And then when you calculate A, you can be able now to calculate what is needed, which is V, speed. Am I making myself clear?
Yes, sir.
Everyone, are you hearing me?
Yes, sir.
Yes,
Yes,
sir.
sir.
Please repeat.
Please come again.
Yes,
Please
sir.
come again. Sir.
Okay, so what I was saying is that from the question, they are giving you the electric field here, which is 20. So that's your E. E is equal to 20, but you can calculate E using F over Q. It's a formula that you can use to calculate E. So right now we are going to equate 20, which is the electric field that you are given, to F over Q. You are given Q, you are given E. So you can make F the subject of the formula. After making F the subject of the formula, you then use that particular F to find acceleration. How do you do that? Using the Newton's second law, which says F is equal to ma. You are given m from the question, and you would have gotten the value of F from the information given here above. So now we have got the value of F. You also have got the value of m. You can be able to find the value of A. When you get the value of A, now you can be able to find the value of V. Why? Because you have got U, you have got T initial, you have got T final, so you can get V. What I'm saying, ladies and gentlemen, I think it's here. Let me show you this diagram. Here it's on the diagram. So you see you are given U. This is your U that you are given. From this that you have here, the electric field, you can be able to find what F, as I was saying. E is given by F over Q. So if you want to find F now, you can make F subject of the formula, and that will be equal to QE. So now, QE, this one here, QE, is representing your force, the same force that you can calculate by saying MA. So if you make A subject of the formula here, you can be able to find the value of A right there. When you do that, you are going to get this as your A. When you get this as your A, now you need to find the speed at t is equal to 5. Then you come to this formula, this one here. When you come to this formula now, V is what you are looking for. U, it's given. A, you would have found it here. Then T is these 5 seconds that they are giving you here. So now you can be able to find whatever that they want you to calculate. Is it making sense?
Yes, sir.
Yes, sir.
Thank you so much. But there's one thing that I think I have to explain to you. And every time when this question is given to you guys, I urge you to get a diagram for it. Without a diagram, you won't take all the marks. And the reason why I'm talking about that is because you see this part here that says in the positive x direction. Then there's another one again that comes and saying in the positive x direction. So you are told that your E, the electric field, is in the positive x direction. So you've got your, what is it? You've got your, remember we are talking about the electric field here. We are talking about the electric field. So it's going to start from this point here. You see this line that I have here? That's when your T is equal to 0. So they're saying the velocity of a particle, this is your particle, Q is -4. At T is equal to 0. Is in the positive x direction, which means it's going this side. This is the direction of movement. This one. Then they went on and say, if the particle moves in a uniform electric field, what is the speed at t is equal to 5? Did you guys know that force and electric field, they oppose each other?
I didn't know that.
Okay, I'm letting you guys know that now. So when the electric field is going to the positive direction, what it means is that the force is going to the opposite direction. That should be known. So let's come to this point here now. So let's assume that the acceleration is this that they got and is negative here. Negative here. Like that. Then we have what? M there. Then you put it here. So M. Then the value that you are going to get here, it's going to be a negative value. Are you getting that? Looks like I'm talking to myself.
No, sir, not understanding.
Or maybe I should leave it.
No, please, sir, can you explain again?
No, sir.
What I'm saying in short is that E and F, They oppose each other. When E is moving to the positive direction, what it means is that the force, it's going the other way around. So basically what would be happening is that I feel like I should not explain this because many people are going to lose me in the explanation. But okay, just to be on the safe side, you should know that E and F, they move in opposite direction. I hope that when we are going to have another class again, I will give you a question where that is applicable, because it can actually ruin your answer if you don't know that. Especially in a situation like the one that we have here. You really need to understand what I'm trying to tell you. But since this question is a bit straightforward, I think I don't need to ruin your understanding from this one. But what I will do in the next class before you write, I will bring you a question whereby you need to apply what I'm just letting you guys know. I think that way it's going to be safe for you. But for now, given what is here on the question, did you get how did they end up coming up with the speed? Did you get the explanation on how to to use the relationship between E and F to come up with acceleration that will help you to find speed? Did you guys get that?
Yes, sir. Yes, we did.
Yes.
Yes, it did.
Thank you so much. Thank you. So it should stick in your mind that E is equal to Q, so to F over Q. So when you have a situation like that, you can convert it to get F. After getting F, still the same F that you have can be written as MA. So you can convert that F into MA, then extract acceleration from that. The same acceleration that you extract, you can use it to calculate velocity. It's just a matter of playing with formulas. I hope it's making sense, guys.
Easy.
Thank you. Let's go to the last question, then we'll call it a day. And this is the last question. They are saying if A is that and B is that, then you are given Q1, Q2, and Q3. They are saying in the figure. Then what is the magnitude of the total electric force on Q? Unfortunately, I think I forgot to copy the figure, so I'm going to give you straight to this. So this is the question, guys. You have Q1, which is this one. You have Q2, which is this one. And then you have Q, which is this one. And they are said to be in this figure. Then the question is, what is the magnitude of the total electric force on Q? So we need electric force on Q here. So you are given that the distance between Q1 and Q2 is A, and this is A. And then the distance between Q2 and Q, it's B, and it's this one. So it's very simple, guys. We want to know the force that is acting on Q here. So first of all, let's take a look at Q1. According to the question, Q1 is negative. Can you guys see that? Hello?
Yeah, bro. Yeah.
Good. Since Q1 is negative, with respect to Q, Q1 is going to exert an attraction. So the force Q1 is going to cause this Q to go this direction. So we'll have a force called F of Q1. on Q, ne? This one, it's F of Q1 on Q. Why? Because Q1 is negative. So this force is going to travel a distance of what? A plus B. Why? Because it's going to travel this distance plus that. Am I making myself clear?
Yes.
Good. Then we look at Q2. What is the effect of Q2 on Q? Q2, if you go back to the question, it's positive. So since Q is also positive, so Q2 is going to force a repulsion. So this one is going to be forced to go this side. So this one is going to be the force applied by Q2 on Q. And the distance that it's going to travel, it's going to travel the distance, this one, which is B. So here you have B as the distance. Here you have A plus B as distance. So now when you're asked to calculate the magnitude, now the magnitude is equal to simply the summation of forces most. So the magnitude is going to be this force that is going this side minus this force that is going that side. So that's why you see here written summation of forces in X is given by F2 minus F1. Then you'll be able to get all your marks. Am I clear?